we get to finish off the chapter, and in doing so, we're going to talk about absolute value equations. Again, if once you learn just the basic form of this, solving your homework problems is not that difficult, but you have to know the setup. So here we go. For a greater than 0 and an algebraic expression given as a capital X, and that algebraic expression, that capital X, I mean it could just be X, 3X, a binomial, it could be a polynomial, okay, but that's your expression. A is going to be some number that is greater than 0, such that we have the absolute value of X equals A. And that is equivalent to simply saying my expression, whatever it is, equal to the plus and minus values of A. So the expression equals a negative A and the expression equals a positive A. A must be greater than 0 because we're dealing with absolute value. The definition of absolute value is the magnitude of a real number without regard to its sign. And magnitude means like size, right? Distance. With absolute value, one of the simplest ways to think of it is absolute value is simply the distance from 0 of whatever the absolute value is. So whatever number we picked, the absolute value of a negative c and c, well, they're opposites of each other. They're just on opposite sides of 0, and they're both the same distance away from 0. Again, distance is always positive. In our minds, we may think, okay, well, I'm flying down to Anchorage, so that's positive, and then whenever I'm flying back, that's negative. I mean, you could have that mindset, but no matter what, it is a positive number whenever you just deal with distance. And again, absolute value of negative c is c, and the absolute value of c is c. Oftentimes, what you're taught in, say, elementary school or like fifth or sixth grade math is that it just becomes a positive number versus understanding what does absolute value mean. Simply put, it is the distance from 0 for a real number. So let's look at an example, okay, to see just that. Visualize what we're doing. So here's my problem. I have to solve for the absolute value of x equals 3. So x, that's my expression, right? And a is my constant or my number. And we know that whenever I have the absolute value of the expression equals a, I take that expression and I set it equal to the negative value and the positive value. So what I'm looking at right here is x equals a negative 3 and x equals 3. Of course, those are my zeros. Those are my x-intercepts. But this is simply a horizontal graph, what I'm looking at, a horizontal line. Both are 3 units away from 0. Negative 3 is 3 units away from 0, and positive 3 is 3 units away from 0. Therefore, the absolute value of a negative 3 is 3, and the absolute value of 3 is 3. That was a simplistic example, one in which you understand and work that problem, but conceptualize what I'm talking to you about concerning distance from 0. More complicated one. So what I have to do is I need to combine any of my like terms, or in essence, I need to get the absolute value, the expression by itself, because I know that this right here is x, and these two together, once I combine them, will be a. So I'm going to subtract 3 from both sides because I want this form right here. I end up with the absolute value x minus 2 is equal to 6. So my capital X is x minus 2 and my value for a is 6. Therefore, value of a, I need a negative and a positive. I set it equal my expression to the negative 6, positive 6, and solve. These are my solutions. These are my roots. These are my zeros. I need to verify that both of those will be true for what I have. We're not going to verify on this one because what I want to do is show you the graph. Now, Desmos has issues with absolute values, and what I would have to do is type in different equations to make it look the way that it should. So for this equation, what I have entered in, ABS stands for absolute value. So this is what I actually have entered in. I have the absolute value of x minus 2 minus 6. The reason I did that is because you don't have an equal sign whenever you're putting in your functions. You need to have everything on one side because, again, what does all of this equal right here? Well, it equals f of x. Understood? Okay, so that being said, let's actually look at this. And I know it's difficult to see, but 6 is my lowest point on that graph. That's my minimum, local minima. But if I look up here at my zeros, again, we ended up with a negative 4. So 1, 2, 3, 4. There's my negative 4. And 8. 1, 2, 3, 4, 5, 6, 7, 8. Those are my zeros. And it going all the way down to negative 6 makes sense. Okay, if I look at this equation, what I have right here, that whenever I have values, for instance, whenever x is 2, that's at its lowest point. Because whenever I plug in a 2, 2 minus 2 is 0. 0 minus 6 is a negative 6. So my domain for this is going to be negative infinity to positive infinity. And my range for this will be a negative 6 to infinity. That's as low as it goes, negative 6. And as I extend out, these keep going on forever until infinity. Alright. Now, what I would like for y'all to do is to solve this equation. Pause the video and let's see if we end up with the same answers. Alright, so what I hope that you did was that you turned around and you wrote out that you know that the absolute value of your expression is equal to A. And from that you know that your expression is equal to a negative A, and your expression is also equal to A. And then we just need to make sure we identify. Okay, I know that this is going, that this is going to be my expression, and these two combined are going to be A. So let's go ahead and combine those. I end up with the absolute value of x minus 4 equals 6. I subtracted 3 from both sides. So what I know is that this is x, so I'm just going to say x minus 4 equals a negative 6, and x minus 4 equals positive 6. And now I solve. I add 4, x equals a negative 2. I add 4, x equals 10. These are my solutions. Verify. Well, I know that plugging in a negative 2 is not going to mess anything up, and I know plugging in a 10 is not going to mess anything up. These are my solutions, my roots, my zeros, my x-intercepts. And that, ladies and gentlemen, is absolute value. Key premise also, if you move up in math, there's so much that you can cover in algebra, but basic premise for your absolute value, and I may do a video on this later, is something that looks like that. It looks like a V, and it will be symmetrical. Alright guys, continue to watch the publisher videos, structure and critically think about your homework. Good luck with your homework.